So we are discussing about the queuing system, a long run measures of a performance of queuing system, some parameters to be studied, some criteria, important criteria. Let us discuss. So primary long run measures of performance of a queuing system are the long run time average number of customers in the system. They are all identified with the notation say L, okay, and in the Q say LQ, the long run average time spent in the system, which is identified as W, and in the WQ as per the WQ per customer. um, and the server utilization or the proportion of time that a server is busy. Okay, you can consider this as a P for your sake of for sake of convenience. Okay, the the term system usually refers to waiting line plus the service mechanism, but in a general, of course, waiting time plus, this is the general scenario everywhere, waiting plus service, which will give the overall system time, but in general can refer to any subsystem of queuing system. The concept of waiting comes over there. Time average number in system L. Consider a system over a period of time t. Let t be the simulation time. Any system it can be a grocery store, or it can be a ticket counter, whatever. And let L of t denote the number of customer in the system at a time t. That's it. Very simple to understand. L of t stands for what? Number of customers in the system. It may be 1, 2, 3, 10, or whatever. Let Ti denote the total time duration. Ti means what? Total time duration between the windows 0 to T. Let it, capital T is the stopping time, maybe 60 minutes or 2 hours, 120 minutes or whatever. It starts from 0. Always in simulation we start with 0, right? Recall the first module things, in which the system contained exactly I customer. I stands for the total number of customer. Um, Figure 6.6 they are saying. So this is what the diagram they are referring to. Okay, as per the below diagram or example, what they are saying is, it is seen that t naught equal to 3, t naught equal to 3, or t1 equal to, yeah, here t naught equal to 3, t1 equal to, say here, 12 they are saying, t2 t2 4, T3 1, and so on. The line segment whose lengths total T1 equal to 12 are labeled as, yeah, T1, total length of the line segment, which is equal to 12 they are considering. We'll calculate it, okay. T naught is said as 3 because see T naught, which is observed between 14 and 16th minute, right? What is the length? 14 and 16. Length is 2 here. Again, it is observed between 2 and 3. Observe carefully, 2 and 3 in between. T naught is observed. So total length of T naught is equal to 1 plus here 2. Total it will be 3. Similarly, for T1 you can count. For T1, here we have 2 minutes, right? 0 to 2 actually. Again here 2 minutes we have, 3 to 5, so 2 plus 2 4. 4 plus 4, how much? 4 plus 4, 10 to 14 is 4. 4 plus 4, length is 8. Length is 8 plus here 16 to 19. 16 to 19, isn't it? Sorry, 16 to 20, sorry 16 to 20. So 2 plus 2 it is 4. Concentrate carefully. 2 plus 2, if you want let me highlight it. Yeah, two minutes plus 2, total 4 we have. 4 plus 10 to 14, how much? 4 minutes. 4 minutes plus 16 to 24. So 2, 2, 4 plus 4, 8 plus 4, 12. Similarly, you can observe T2. T2 is what? Carefully you observe. In between 5 and 7 it is there. Here duration is 2 plus 2, 4. Isn't it? 4. And what is T3? T3 is 1 as per the diagram. Right? In general, sigma Ti which is equal to T. This is of course because Ti is what? Total number of customer in any interval of time. Total duration is T, isn't it? So summation of all the intervals will give you the total duration only, isn't it? From I is 1 to infinity, sorry, I is 0 to infinity, Ti, summation of Ti, which is equal to total duration T. The time weighted average number in a system which is defined as, okay, the time weighted the average number in a system is defined as L cap, L cap, which is equal to actually Ti by T, Ti by T. Please remember I into Ti by T. Summation I is 0 to infinity. So this will give you the average value of the customer at any interval. Please remember this is used to calculate the average number of the customer. Total duration T, which is equal to 20, because what is total duration? Total duration, if you see the graph, you will come to know total duration. It is started from 0th minute and it is ended at 20th minute. So total duration will be 20 only. If you add these, you will get 20 once again. Because summation of Ti will give you T only. You can add these numbers 3 plus 12, which is 15 plus 4, 19 plus 1. Isn't it? So I is the interval. You have to apply the formula. The same formula. Go for summation of I into Ti, where I is the step number. I interval number starts from 0, right? All the simulations are started from 0. Please remember. Interval 0 into at interval 0 T naught. Check the statement. What is the value of Ti? Which is equal to 3 minutes. In addition with summation means you have to go for addition. Next interval T1, that is 1 into what is value of T1? Substitute 12. In addition with T2 use suffix 2 in multiplication with what? Multiplication with 4, right? In addition with T3, that is use 3 in multiplication with this value 1. What is the total duration? Total duration will be 20 minutes, right? So 0 into 3 plus 1 into 12 plus 2 into 4 plus 3 into 1. What will be the answer? 1 into 12 is 0 into 3 is 0 plus 12 is 12 plus 8 plus 12 plus 8 plus 3. Where 12 plus 8 is 20 plus 3 is 23 divided by 20. What is the average value? 1.15 customers. Okay, very simple thing. Similarly, we can find the average time spent in a system per customer. Average time spent in a system per customer, right? Because it depends on it varies from customer to customer. A customer may stay for 1 minute and complete his job, or a customer may even stay for 10 minutes also in the system. Depends on the type of the job as well as depends on the waiting. But we can compute the average value, the common value for all the customer. How? With the help of some sort of formulas. If we simulate a queuing system for some period of time, say T, then we can record the time each customer spends in a system during the interval. What is the interval? 0 to 2 is T is the interval. Say W1, WB, W2 and Wn, where N is the number of arrival N is the number of arrival, or in other words number of customers, right, in the duration 0 to t. So the time spent in a system, or the average system time per customer, is given as follows. This is the formula, where n is the total number of arrivals, or in other words total number of customers. You can say 1 by n summation wi, where I ranges from 1 to n, right? For any stable system, value of n will be infinity only, right? There will not be any restriction for the stable system. In real time, actually any number of customer can enter, or any number of arrival process can be observed. So for such systems, w cap which will be same as, or which is equal to w. So with probability 1, where w is called the long run average system, its value will remain. It tends the value of w. This is what the definition part of average time spent in a system per customer. There are some other topics, important topics in this module. Let us see them in the next session. Thanks for watching.